Good morning, dear students. Welcome back to Target JEE Class 12 Physics. We are in first lesson Electric Charges and Fields. In this, we are going to discuss today the equilibrium. So, in first case, we will discuss the equilibrium of charges between two fixed charges. So, let us consider two charges plus Q to two similar charges, equal charges, and we'll have a small plus q charge exactly at the middle. If I move this charge through x distance, then what happens? This charge comes closer to this charge, so both are like charges, so repel each other. So because of repulsion, this plus q goes to this side. When it goes to this side, it becomes near to plus q. So because of once again the repulsion, it goes this side like this. About this position O, I may call it O. It may be, I will name it as AB. So this body, this small charged body will oscillate about the point O. This line which is drawn joining the two centers of charges is called axial line. This charged particle oscillating on axial line and coming back to its mean position after some while. So it is in stable equilibrium. So for this system, stable equilibrium, so stable equilibrium of this positive charge plus small q lies along axial line. What is stable equilibrium? Stable equilibrium is a point about which a charged body oscillates, a charge oscillates. So stable equilibrium is at O, that O is along axial line. If I disturb this charge, if I move this charge upwards at x distance, see, if we draw a perpendicular at the center of axial line, this line is called equatorial line. This line is called equatorial line. So if I move this plus q along the equatorial line to x distance, now the plus q is here. Then what happens? This plus q, capital Q, repels this plus small q along the direction which so it is a central force along the direction which joins the positions of a body, charges, positions of a charges. Here also, this is the line joining the two charges. This plus capital Q will repel this plus small q in this direction. So simultaneously, if these two forces are acting on plus q, it will be kicked off in this direction. The plus q plus small q will go along the resultant force direction. Same to same here also, if I place plus q here, if I displace it, so this also repel and this also repel, so it will go into, so it cannot come back because of repulsion. It is going out of the system. That's why it never comes back to its mean position. That point is called unstable equilibrium. Unstable equilibrium point lies along equatorial line, right? So let us now consider, here in the middle we have placed a plus small q. So once again I will take 2 point charges, similar charges, plus q, here plus q. These two charges are fixed at some distance, exact at the midpoint of them. Now I have taken minus small q. Let us see where the stable and unstable points are there. So if I, as usual, move this small q through an x distance along axial line, this is axial line. So this is axial line. Then what happens? This minus q come closer to this plus q. They are unlike charges. Unlike charges attract each other. So if I disturb this minus q through x distance, immediately the distance between this plus q and this minus q decreases. Whenever the distance between the charges decreases, the force, electrostatic force, Coulombian force increases. So this negative small q will be attracted and it will go near to positive q. Simultaneously, if I move this here also, it will go into positive capital Q. It won't come back to its mean position. So if it cannot come back to its mean position, the original position, the mid position, we call that unstable equilibrium. So here minus Q, unstable equilibrium, unstable equilibrium, where it lies along axial line, along the axial line. Now if I move this small q an x distance, this line, a perpendicular bisector which is going to the center of this axial line, is called equatorial line, we know it. So equatorial line, if we move this through x distance, now minus q is there here, then what happens? This plus q will attract this minus q towards it, and this plus q also attracts this minus q towards it. So when two forces simultaneously acting on a body at some angle, the body moves in the direction of resultant force. If I place here negative q charge, here also this plus will attract this minus q towards it. This plus q also attracts this minus q towards it, and it will move towards the mean position. So what happens because of this? This minus q will oscillate, and after some time slowly it come back to its mean position. So the stable equilibrium lies along the equatorial line if between two positive fixed charges a negative charge is in between. So stable equilibrium lies along equatorial line. So these points you have to remember. Many a time in JEE problems came on this concept. So what they asked, see, whenever stable equilibrium is established, the charged particle, a charge, will oscillate about that equilibrium position. So when it is oscillating, we've been asked to find the angular frequency or frequency and time period. Like that problems will be asked in JE. Let us consider as usual two similar point charges, a plus q here and another plus capital Q here. This is position A, this is position B. The distance between them is 2r. Exactly at the midpoint, I may say that is O, which is at a distance r. We have placed a plus q. This is our first case. So what happened for this system? The equilibrium, stable equilibrium point is along the axial line. So I have moved this to x distance. Now the plus q is not here, the plus small q is here. So what is the C? When we want to calculate the force, so we need the distance between the charges. So this distance we have to calculate. What is this distance? This is r, r minus x. This is r minus x distance. That distance is useful for to calculate the force between plus q and this is small q. What about this which is at B? So its distance between this plus q at B to q. This is r plus x. Now we can easily calculate the force, net force acting on this plus q. So net force acting on this one is equal to C. When this plus q is here, this plus q at A will repel this plus q in this direction. This is force due to a charge at A. B also repels, but the repulsion is as the distance between the plus q at B and plus small q, distance is more, so feeble force, the force value will be less. This is because of B. So I will subtract both of them, FA minus FB. The nature of this force is repulsive. That's why minus I have written. So net force is equal to minus of FA formula. I will write K capital Q small q by the distance between A and plus Q. So that is R minus X whole square minus here K capital Q small q by the distance between the charges R plus X whole square. Right? Now let us simplify this one. The net force is equal to minus K Q small q. I have taken common. Then I got here 1 by r minus x whole square minus 1 by r plus x whole square. So I will take a LCM. Fn is equal to minus k qr LCM r minus x whole square into r plus x whole square. Here r plus x whole square minus r minus x whole square. So we know that a plus b whole square minus a minus b whole square is 4ab. So Fn is equal to minus k q small q common 4 rx by r minus x whole square into r plus x whole square. How much it is? R power 4 minus 2 r square x square plus x power 4. Now here the x distance is very much less than the r value, but x is very much less than r. That means what? X square value can be neglected. Right? 6 into 0.01. So it becomes 0.06. So whenever a multiplication or squares are there, when value is very small, the result also becomes very, very small when you square it, right? So because of this, what happens? Here x square is there, here x square is there. Total term can be neglected. Total these two terms can be neglected. Then what we get? Net force is equal to minus this K Q small q within brackets 4 Rx by R power 4. Here r power 4, 1 r will go, here 1 r will go. So finally what we get? Fn is equal to this 4, I will write like this, minus 4k q small q by r cube into x. We know that the net force formula F is equal to ma minus here what got 4 k q small q by r cube into x. So A is equal to minus k 4 k q small q by this m comes here mr cube into x. This is equation 1. The acceleration of a particle which is oscillating about its stable equilibrium, that acceleration came. It is oscillating, it is executing SHM. So this charge can be taken as SHO, simple harmonic oscillator. The acceleration of a simple harmonic oscillator is equal to minus omega square x. The acceleration of a simple harmonic oscillator is minus omega square x. So we will compare equation 1 and 2. This omega is equal to under root what came 4 k q by m r cube. This is the angular frequency of an oscillating charge, and we know that omega is equal to 2 pi f and omega is equal to 2 pi by capital T. By using these two formulae, we can also calculate the frequency, we can also calculate the T. So in the place of omega, if you write 2 pi by T, you can calculate T. If you write 2 pi f in the place of omega, you can calculate the frequency of oscillation as well. So like this, we can calculate. Let us calculate the angular frequency of the case 2 also. What is the case 2? Two point similar charges are there, plus q plus q. Now the separation between them is 2r, and exact at the midpoint minus q is there here. This is r distance. Where lies the stable equilibrium point? Along the equatorial line. For if a minus is there between two similar positive charges. So this is equatorial line. On the equatorial line, I just moved this small q. Now it is not here. X distance. Now small minus q is there here. Then what happens? This is the line joining the two charges. Always this attraction or repulsive forces acts along the line joining the two charges. Right? This is our minus q. Now it is x distance. So this distance is r. Distance is r. This distance also r. Right? So here this minus being attracted by this one, and this also attracted by the plus q. Here also similar charge, here also same charge, so forces are equal. So I will take this is theta and this is also theta. Then net force. So what is the net force here? Net force acting on minus q here is, right, this is F. So towards the C it will go like this. Because of these two forces, the resultant force is in this direction. So this is the resultant force direction. I will write x here. This is the direction of resultant force. So this resultant force is this F. Theta is there. The resultant force is adjacent to this theta. So cos theta. This is cos theta. This is cos theta. It is down. That's why minus 2f cos theta. Right? This is f cos theta. This is f cos theta. 2f cos theta downwards acting. So minus 2f cos theta. So Fn is equal to, I will write the formula for F here. So F formula is K capital Q small q by r square. R means here the distance between the charges. The distance between charges. This is x, this is r. So this is root of r square plus x square. So root of r square plus x square whole square into cos theta. Now Fn is equal to minus 2 k capital Q small q by root r square plus s square whole square, that root will go. So r square plus x square cos theta value. In this right angle triangle, here also you can take, both are similar. Here also angle is theta only. So cos theta is adjacent side by hypotenuse. Adjacent side by adjacent side is x. Hypotenuse is root of r square plus x square. So let us simplify this one. Let us simplify this one. So Fn is equal to minus 2. Here I'll write like this, minus, I'll write outside 2 k capital Q small q by r square plus x square into r square plus x square, root means whole power 1 by 2. 1 plus 1 by 2 is 3 by 2. So I'll write r square plus x square whole power 3 by 2 into x. So here as usual, but x is very much less than r, so x square value neglected. So we have neglected x square value here. So if I neglect x square, this 2 will cancel, that r cube will come. So Fn is equal to minus 2 k q small q by r square, this square 2 will cancel, it becomes cube into x, like this. But now the resultant force MA is equal to minus 2kq by r cube into x. This m I will send to that side. A is equal to minus 2kq small q by mr cube into x. So this is the acceleration of our charged particle about its stable equilibrium point. As it is executing SHM, the simple harmonic oscillator acceleration, we know that minus omega square x. So by comparing both of them, in the place this omega root of 2 k capital Q small q by mr cube. This is angular frequency. This is angular frequency of a oscillator. This small q. Right? This formula you can remember. If for frequency we want, you write in the omega place 2 pi f you write. Then this is root of 2k capital Q small q by mr cube. So this pi comes here, f is equal to 1 by 2 pi root 2k capital Q small q by mr cube. This is the frequency. Time period also we can calculate. How? In the place of omega, I will write 2 pi by capital T. If I write 2 pi by capital T, then the time period formula becomes T is equal to 2 pi root this will come like this, mr cube by 2kq small q. This is equation 5. Like this, whatever been asked in the problem, we can calculate for this particular case. Let us move on to another case of equilibrium. See, let us consider a rigid support is there. From the rigid support O, from the same point, two pendulum are suspended from same point. This wire is non-conducting. These spheres are metal spheres. They have given a positive charge. So both are similar charges. This is also plus small q. This is also plus small q. As both similar charges repel each other, they have separated a distance 2r. I will draw a perpendicular bisector here. So this is a bisect. So this point is O, this point is A, this point is B, like that. Just to remember, to recognize, I have given some names. So this total angle is theta. So this half angle is theta by 2, right? So this distance became r. This distance became r. These plus q, two are separated and they are in equilibrium. Why? Because of repulsion, they went some distance and they are stable there. Then, what are the forces acting here? Up downwards, vertically downwards. Let the bob mass is m. So mg weight is acting vertically downwards and the repulsive force is acting in this direction. This positive charge will repel this positive charge in this direction. Whenever the string goes like this, in the string, tension T is acting. So tension T is acting, so I can resolve this tension into its components. So I will resolve these components. Then this is also becomes theta by 2. If this is theta by 2, this is also theta by 2. So in this direction, what is there? T, this is adjacent, cos theta. T cos theta. In this direction, T sin theta, obviously T sin theta. T cos theta, T sin theta are the orthogonal components of capital T. All the forces are equal and opposite. That's why this bob is in equilibrium. At equilibrium, F is equal to T sin theta, mg is equal to T cos theta. These equations you do remember. Often these concepts are asked in JEE exams. Mg cos theta. So I can also write F by mg is equal to, if we divide it by here, what happens? T will cancel, sin theta by cos theta is equal to tan theta. This is another relation, right? By triangle of vectors also will have one relation. Triangle of vectors says that, see, the triangle we can imagine. This is B, this is O. Sorry, I have given O, na? So sorry, this is C I will give. This is a C because here I written O, right? So this is theta by 2. Triangle of vector says a force can be represented both in magnitude and direction by the two sides of a triangle taken in order. In reverse order, they give the resultant. So, F can be represented by CB. MG can be represented by OC. So these are the important relations. So if you remember all these formulae, very quickly you can answer any question relating to this one. One more case is there in this. Total arrangement if immersed in a liquid, what happens? Liquids are having the densities, right? See, for that particular thing, this is a rigid support. This is the two bobs having mass m separated some distance. This is perpendicular bisector. This is O, this is C, this is A, this is B, right? This total arrangement is submerged in a liquid. So total arrangement is dipped into, submerged into a liquid. Then the relations we have to establish. This let us say this distance all same names I am using. If not, I will write this is theta by 2. We know it. This is angle theta. This distance is r, and the separation is 2r. Then forces acting. This force is F, result repulsive force. This is weight mg. This is tension. But one thing, whenever it is submerged in a liquid, see the G value changes and F value also changes. Why? The Coulombian law, the force, Coulombian force, electrostatic force is defined when the two charges are in vacuum or air. If some medium is there between the charges, medium will affect the magnitude of the force. That's why this force is different and this G also different. When G changes, when it is submerged in a water or some liquid. So liquid is having liquid density rho L. This solid bob is having solid density rho S. So then the F dash becomes 1 by 4 pi epsilon naught epsilon r, then q square. This is also q, this is q and q square by distance 2r whole square. This is the force. Mg dash is equal to, actually effective G value you always remember in fluid mechanics we got this relation. Don't forget G into 1 minus density of liquid by density of solid. This is effective G when any solid is submerged in a liquid. So here in the place of G we will get m G into 1 minus rho L by rho S. This is, so like this, these two formulae will change F by mg. So here F dash mg dash. Like this equations will change. So this is all about equilibrium. So I think you are understood the concepts, and next problems video is there. So on this concept, whatever the concepts we have discussed, so we solved 12 to 15 problems in that one. Go through those problems and do as many problems as you can. Then you will get the firm grip over the concept and application of concept. Application of a concept is more demanding thing to get good marks in JEE exam. Thank you.